Uh, Now see this, using this lock variable, what we did was, if lock variable is 0, both P1 or let us say P0 and P1, they are the two processes. It is, any number of processes can use this, but let us say P0 and P1, only two processes are there. Both of them can enter, and if it is 1, no one can enter. And then we use the turn variable. Using the turn variable, if turn is 0, then P0 can enter. If turn is 1, then P1 can enter. Right? So here there is a chance that there could not be any mutual exclusion, but here there is a chance that there is mutual exclusion but no progress, right? Now why is there no progress is, if the other process is not interested, still you are stopping one process, even the other process is not interested. Therefore now I want to use a new, instead of using one variable I want to use two variables, like this. Interested of 0 and interested of 1. So if any process wants to get into the critical section, it should say that it is interested, right? Otherwise it should say that it is not interested. So before entering the critical section, you say that you are interested, so that other party will know that, oh, you are interested in entering the critical section, so that will wait, right? Maybe now using this, see here the difference is, till now we are using only one variable, here I use two variables, right? So using two variables, then 0 process P0 will use this and process P1 will use this. So I am even increasing the space at which they will compete. So earlier they are competing at the same value, they are competing at different values. Now they are competing at different variables. Now let's see how to write the solution for this, the synchronization mechanism, and we shall analyze it. Okay. Now P0, as long as it is in non-critical section, fine. And if it wants to enter the critical section, I am talking about the entry section here. It should say that interested of 0, which means the variable for 0, interest of 0 equal to true, which means I am interested in entering it, and then it should even check the other one, right? While interested of 1, the process 1 is equal to true, which means if the other one is also interested, then you should hold, because the other one is actually interested, therefore you should not enter it. Got it? And then after that, entry section, you are going to enter the critical section and then exit. So when you are going to exit, you can write it as you are not interested anymore. Interest of 0 equal to false, right? And similarly in P1 also we could do the same thing, right? In P1 what we can say is, if you are in non-critical section, be there as long as possible, as you wish, and then once you are entering the critical section, if you want to enter the critical section, then what you do is you show your interest, which means interested of 1 equal to, let us say you are interested in entering it, therefore interested of 1 equal to true, and even you check the other one. If other one is interested, the chances are that the other one might be already in the critical section, or it has already shown its interest first, well ahead of you, therefore give it the chance. So while interested of 0 equal to true, then you wait here for the other one to go into the critical section, right? And once the other one comes out of the critical section, it is going to say you can enter the critical section, and then you can say interest of 1 equal to false, right? This is the exit. So this is how you can implement one more synchronization mechanism. Now let's see if mutual exclusion is possible, which means is it possible that both the process can enter the critical section simultaneously. Observe this. Let's see this. Now interested of 0 initially is false, and interested of 1, int is not integer, it is interested, right? And it is false. Now when P0 wants to enter the critical section, now it will make the interested as interest of 0 as true, and it will see that other one is not interested, therefore it can enter the critical section. Let us say P0 is in the critical section. Then what happens? Obviously interest of 0 will be true, right? And then now P1 tries to enter the critical section. What it will do is it will make interest of 1 as true, right? But then it will find out here that 0 is already interested, which means the chances are that 0 might already have entered the critical section. In this case it is true, therefore it is going to hold here, it is going to stop there, right? And until what point? Until this one comes out. So you are going to stop P1 at this loop until P0 comes out. Once P0 comes out, it is going to make it as false. Now next time when P1 gets the chance, this while loop will break, because interest of 0 is not true now, it is false. Therefore this one will break and it will enter this critical section. Like that it will execute. Got it? Therefore mutual exclusion is guaranteed. The reason is simple. Even if both the process watch the interest at first, whoever enters this, and passes this while loop first, right, they are going to get into this. So therefore using this solution, mutual exclusion is guaranteed. What about progress? Mutual exclusion is guaranteed, I'm sure. I mean, just check it, because only one process can enter it at any time. Mutual exclusion will not be guaranteed only if we are letting two processes or more processes enter into the critical section on the same condition, like L equal to 0. But here they are not entering the critical section on the same condition, they are entering the critical section on a different condition. Here we are setting interest of, this is checking interest of 1 and that is checking interest of 0. So both of them are different. See, if you have any doubt, just analyze this a bit more. See, now let us say this is interest of 0 variable and interest of 1 variable. What are the four cases? Interest of 0, both of them can be true, 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 false, false, true, false, false, right? So in this case no one is interested, therefore there is no problem with this. In this case only I1 is interested, therefore who will get the chance? P1. So I1 is having true value, therefore it means that P1 is interested and other one is never interested, therefore P1 can enter the critical section. In this case P2 can enter the critical section, sorry, I0 can enter the critical section, because only that is interested. In this case, which means if both are interested, then there is a problem. If both I0 and I1 are interested, then who will enter the critical section? The one which has set its interest first and the one which has entered this. But then there is a problem here. Okay, I'll show you that problem. But anyway, here only one process, either P0 will enter or P1 will enter. That depends on who has actually passed this while loop first, isn't it? If P0 has passed the while loop first, these two executed first, then P0 will enter it and P1 will hold there, even though both are having interest equal to true. Let's say there is a problem there. I know you got it, but let's hold on. Let's go step by step. First one is mutual exclusion, it is guaranteed. And next one is progress. Progress is guaranteed. The reason is, see, if one process is not interested, it can never stop the other process which is interested. Why? Because we are clearly checking if the other one is interested or not, isn't it? If the other one is not interested, it can never stop it. And then what about the next one? Bounded waiting. What is bounded waiting? Anyway, it is a two process solution, right? So bounded waiting means if one process wants to get into it, the other process, like this, it would happen like this, P0 and then P1 and then P0, something like this, right? So let's see if bounded waiting is possible or not. If P0 wants to get into the critical section, let us say it got blocked, right? Then what happens? The other one which got the permission, see this, let me write it here. See, initially assume that both interest of I0 equal to false and interest of I1 equal to false, right? And P0 wants to enter the critical section, and therefore P0 will make I0 equal to true, right? And then it will enter the critical section, and it is there in the critical section. At that point P1 wants to enter the critical section, therefore it made I1 equal to true, right? Then what happens? If when it made I1 equal to true, right, and it will get stuck in the while loop. In the while loop it will get stuck. The reason is other one is still interested. So next time P0 comes out of the critical section and then it will make interest equal to false, right? Let us say after some time again P naught only wants to enter the critical section, which means let us say this is in a while loop. It is not just over in one time, it is in a while loop. It will continuously happen, right? And here also everyone wants to enter the critical section continuously. They want to come out of it and again enter it, right? Then let's consider this scenario. P naught came out of the critical section and showed that it is not interested. Again it want to enter it, which means it immediately made I naught equal to true. Now if it wants to enter it, it will just check the interested, right? While interest of other equal to true. Yes, interest of other equal to true. Therefore this time it is going to wait in a while loop. And now what happens to the other one? P1 again it will try to execute, then again it will be in the while loop showing that other one is interested. Now both of them are interested and both of them will be in the while loop. So it is not just bounded waiting, it is a deadlock. So deadlock is possible. The reason is when both of them show that their interest is true, and both of them get preempted, which means P0 has executed this line, got preempted. Then P1 has executed this line, got preempted. Then P0 will come and check that the other one is interested and it will be in the while loop. And P1 is also come, it will check that the other one is interested and it will be in the while loop. Therefore, there is a deadlock. Whenever there is deadlock, there is no bounded waiting. Isn't it? Deadlock is more severe than bounded waiting. The process are going to wait forever. They are never going to get out of it. So the problem with this is deadlock. Even though there is no assumption about the architecture, it is architecture neutral. Fine. The problem with this one is deadlock. So progress is guaranteed here, but we came across the problem of deadlock, right? So if you look at the turn variable, mutual exclusion is guaranteed, but progress is not guaranteed. But bounded waiting is guaranteed. Is bounded waiting guaranteed? Yes. Bounded waiting is guaranteed, and architecture neutrality is guaranteed. Now, individually, interested variable is having some problem, and turn variable is having some problem, right? Now, what Peterson did is he combined both these concepts, both the turn and the interested. Now Peterson combined both these variables. One is turn and the other one is interested, and he came up with a beautiful solution using which we can implement the synchronization mechanism in such a way that it will have mutual exclusion, it will have progress, it will have all the conditions. Let's see how that solution is implemented. Okay, I hope that you followed this interested one. While the other one is showing the interest, you'll assume that the other one might have already entered the critical section, and therefore you are going to wait in the infinite loop. And the same thing happens with the other process also. When the other one is showing interest, then we'll assume that the other one is already in the critical section and you will be in infinite loop. Because of this problem, both the process might enter into the infinite loop and be there forever, right? That is why we are not able to do anything with this interested variables. So now we are going to combine turn variable along with the interested variable, and we are going to come up with a beautiful solution that is called Peterson's. That is the most standard solution and very important. We shall discuss Peterson's solution.